Today we are going to talk about chapter 2.7. First, let's consider certain notations. In other words, how we say things and what we mean by them. For example, let's consider the notation 0, parentheses 0, comma 1. That means every number between 0 and 1, but does not include 0 or 1. Okay? To include 0 and 1, we write it like this. You use the bracket. 0, comma 1, and that means every single number between 0 and 1, including 0 and 1. So in this case, what we do is we draw a circle here. That means there's a hole there, right? But remember, the hole is extremely small because the hole consists of 0 only. There's nothing else in it. And then similarly, this hole, it consists of only 1. As an example of this thing is called a set. A set means a collection of stuff, and this is a set of numbers. All numbers that's between 0 and 1. As an example of what's in this set, we can think of, say, 0.5. That's in it, okay, right here. That's 0.5, right? And then, but that's obvious enough. But what about 0.1? Well, that's in the 2, right? It's over here. Anything that's bigger than 0 and less than 1 is in this set. So is 0.01, all right? And then so is 0.000, etc. Eventually get to 1. And let's say, I don't know, let's put 1 billion zeros in here. Imagine me writing 1 billion zeros, okay? I might not live long enough to do that, so we'll just pretend that I did. So let's put in 1 billion zeros in here. So that's a number extremely close to 0, but it's not 0. In that case, that particular number with a billion zeros written is also belong to the set, okay? So that's what this set means. Now the only difference between this and this is that it includes the 0 and 1 together with everything in it. Therefore, this set is completely included in this set. All right, so that is what the first notation means. And the other notations are similar. Next, let's consider the symbol infinity. Infinity means you go on forever. Infinity is not a number. It just means that the direction goes without stopping. Infinity does not stop. Okay, that's a careful distinction that you should make. Is do not think of infinity as a number because it isn't. It just goes on. And infinity means it gets bigger and bigger and doesn't ever stop getting bigger. So, as a result, infinity is bigger than a billion, it's bigger than a trillion, it's bigger than a trillion times a trillion, okay? So that's infinity. It's bigger than any number you can possibly think of because it doesn't ever stop. When you think of a number, it's stopped, and then the infinity runs right past it. So the set notation then is as written here, okay? Now this is the set notation, and it reads as, see the bracelets there? This is how you read this. You read it as the set of all x such that x is bigger than a is less than x less than b, or x is between a and b. The interval, to say this in a shorter way, is that parentheses over there that I show you. You just write down parentheses ab, as in the 0,1 example, and that will be the set. The next notation is the set of all x such that x is bigger than a. The vertical line reads as such as. That, another way of saying it is your set consists of all numbers going from a to infinity, not including a or infinity. Well, if it doesn't include infinity, that doesn't mean anything because it still includes every single big number you can possibly come up with. Okay, because so that's what that means. And then similarly, if you look at the third one, if your set is such that x is the set of all x such that x is less than b, that means that your set ends at b, but doesn't include it because it's a strictly less than symbol. Okay, and then it goes back all the way to negative infinity. Again, negative infinity is not a number, it's only a direction. That means any negative number you can think of, negative infinity is more negative than it. Okay, so that is, so any negative number will be included in this set, all the way up to b. But not including b because it says less than b, so you cannot include it as well. Now, if you want to include it, of course, then you use the bracket instead. See, this is the set from a to infinity, not including a. Here's a set that it does include a. And when it does include a, the bigger than sign is going to also draw a line on the bottom to include the equal sign. So it reads as x, the set of all x such that x is bigger than or equal to a. So that's that set. And similarly for b, the same principle. That's the set of all x such that x is less than or equal to b. Now, and sometimes you can mix up, see, these are both less than signs, but you can mix them up. Say one of them can be less than and equal to, the other one can be just less than. And in that case, you will have a bracket on one side and a parentheses on the other, or vice versa. Either way, the point is that the bracket means including the point, parentheses, not including the end point, but includes everything else, no matter how close it is. Okay, even if it's something like this, it still is part of the deal. So let's look at the next page. More stuff, okay, more similar things. And then you can sometimes, of course, include both endpoints. You have two brackets, and you have two inequality with the equality sign in it, or you can have a set that's the union. That U there stands for union, which means your set can be on one part or the other part. That is, your country comes out of two chunks. Okay, that is either less, in this case, either less than a, going all the way to negative infinity, or bigger than b and going all the way to positive infinity. In this case, it doesn't has the equal sign, but you can choose to have the equal sign, then will mean including a and b, or not including, either way. Now, what if I want to talk about every number from negative infinity unto infinity? Then you just write down parentheses, negative infinity to infinity, or you just say the set of x is all real numbers, which is everything, okay? So that's what that means. All right, so that is the bunch of set notation. Now that we have said that, let's do a couple, do all the examples. Not just a couple, let's do them all. First, example 1. Example 1 says, what do we want? All real numbers greater than or equal to a. So we want the set of, so we read it out like it says, okay? So we need the set, draw the bracelet, of x such that x is greater than or equal to a. So I draw it out like it says, right? The set of all x such that x is bigger than or equal to a, used to indicate greater than or equal to -2. They don't just want a, they want -2, all right? So we will do what they want, okay? And then greater than or equal to -2. So what do they want? They want this is the set notation, and they want the interval notation. So the interval notation, the x has to be bigger than -2. So we start at -2. It includes it, so we use the bracket, and then it's bigger until forever. Okay, so we draw out the positive infinity. And positive infinity always draw parentheses. You don't draw a bracket because infinity is not a number, so you can't include it. Okay, so we always draw parentheses to mean that it's not included because we can't include infinity. Okay, and so that is the answer to example 1. Please do that yourself as well as part of your homework. Next, we have let's look at example 2, where it says write the interval of all real numbers less than or equal to -1. So let's do that. This is problem 1. Example 1, example 2. Example 2 wants everything less than or equal to -1. So x such that x is less than or equal to -1. Did I read that right? Less than equal to, yeah. Or, okay, now to write the or symbol, we will, how do we write the or symbol? Well, I don't think the book says how they want the or symbol written down. So we'll just write down or. That's fine, okay? Let's be ingenious, intuitive, something. Anyway, I'll think about that word later. So less than equal to -1 is not done talking yet. Keep reading. Greater than or equal to 1. Okay, so or x is greater than or equal to 1. So that is what we want, but we will need it to write it in this thing. What is this called? Whatever it's called, we need to write it like that. So then to write it like that, I'll write it up here. So x is less than equal to -1. So we'll write down -1. And is anything less than that? So we'll go all the way to minus infinity and draw the parentheses here because infinity cannot be included, okay? Infinity has no bounds. Nobody is including it to anything. Anyway, so or is the union sign. Well, whatever. And the other option was x bigger than or equal to +1. So being that equal to +1, we have to use the bracket. And then that just greater than, okay? So it goes to positive infinity. So please do that for your homework as well. And next, let's look at the bottom of this page. What page are we on? Well, same page, 162, I think. No, we have moved to 163, fine. So let's, at the bottom of page 163, there are certain properties that we want to mention. First is if A is less than B, the addition property, then A plus C is less than B plus C. That's the exact same property that equation signs have, which means when we solve inequalities, we when it comes to addition and subtraction, we do it the same way as we do regular equalities. Okay. Now the reason this is true is this. For example, let's imagine some numbers such as I'll write it over here. Say 3 is less than 5. Okay, and where A is less than, it says A is less than B, so let's pretend that A is 3 and B is 5. Then if we add something to it, say 2, then 3 plus 2 is less than 5 plus 2 because I'm adding the same thing. The inequality sign will hold, just like the equality sign, see? Yeah, if 3 is less than 5, then this is true also. And that's why this property is true, that when A is less than B, okay, the first one, very important. If A is less than B, then you can add the same thing to both sides and the inequality sign doesn't change, okay? This inequality still holds. So that is true, and that's the first thing. Now secondly, then if A is less than B, then if we multiply it by a positive number, let's say 2, okay? Let's say we do 3 times 2. Is that still less than 5 times 2? Yes, it is, because 2 is positive, okay? Because that's 6 and that's 10. So inequality holds if you multiply by a positive number. It does not, however, hold if you multiply it by a negative number, however, because if you have 3 times minus 2, the way negative numbers work, if you compare it to 5 times -2, then suddenly the 3, this is less negative. Okay, so the sign flips. So as a result, that is an important point to notice, is when you multiply by a negative number, that is when C is less than 0, then you have to flip the inequality sign. And that is the multiplication property. That is the inequalities things that we do almost identical to the regular equations. That is, if we had an equal sign here, the only difference is, however, that when you multiply by a negative number, you have to remember to flip the inequality sign. That's the only difference between equality problems and inequality problems. Okay, and so having said that, that is then let's do an example to see how this works in a homework, of course. And so let's look at example 3 on page 164. Somehow we made it to 164. Now let's look at example 3 on page 164, part A, where we have a simple inequality problem. Now we have now remember that when it comes to plus and minus, we can just act like this is the equal sign and work the same way. So then we will in effect we will add 15 to both sides. Okay, which is the same as pushing the minus 15 to the other side to become positive. So we rewrite this thing as x less than, push the 15 to the other side, and becomes positive, okay? That's the same as adding 15 to both sides. And then that would be x is less than 4 plus 15 is 19, and that should be our answer to part A. All right, now next, let's do part B. Part B says, all right, so let's do part B here. So part B, we have 6 bigger than or equal to x minus 1. If the problem starts out with bigger than and equal to, then you just keep it that way. If it's just less than, you keep it that way too. Okay, just stick with whatever they give us. And so we have this one, and then I like to keep x positive. So we'll write it like this, okay? And then we'll keep the x here. We'll move the negative sign to the other side by flipping the sign. It becomes 6 plus 1, okay? Or add 1 to both sides. Either way, that's the same thing. And so the answer to this question is that 6x is less than 7. Or we can write it the other way, which is like this, okay? And the less than sign has to follow, see? The less than, the smaller side, right? The smaller side follows. So x is less than 7, and we can write it like this. Well, your book didn't even bother. Okay, your book just had it like this, which is fine. Nothing wrong with that. And finally, problem C, we have, let's see, what is problem C1? X plus 7 is bigger than 9. And similarly, we'll push the 7 to the other side. We'll keep x where it is, I guess. So that becomes 9 minus 7. Anytime it crosses the equality or inequality sign, okay, we have we will have flipped the sign. So that will be equal to x. X is bigger than 2. That should be the answer. Yep. So we did three parts very quickly because these are just simple little things to show you how this works. And so please do example 3 as part of your homework. And then we will, next, let's consider example 4. So example 4, part A, let's do it. Okay, so next, let's do example 4. Okay, let's see, well, write down part A here, maybe. Okay, let's see. What does part A want? Part A is 3x less than 6. Now, as you can see, this kind of problem is a lot like equalities, right? So you do it exactly the same way. So this is 3 is positive. Remember, dividing by positive numbers doesn't change a thing. So we can just do it like we do in equations. So then you push the 3 across it down, okay, as a division. And then so then the answer is x less than 2. That is the answer for part A. Yeah, that's correct. And then let's say part B. I'll write it maybe over here. So part B, we have minus 2x and minus 1. And that is bigger than equal to 5. All right. Now this time we have, so we'll move the minus 1 to the other side. That becomes plus 1, so 5 plus 1. And then that would be equal to 6. And then remember the flipping the sign business, because we have to divide by negative 2, okay? We're going to push the negative 2 down to the bottom. But in doing that, we have to flip this thing. So that becomes, what's the flipping sign look? There, right? Yeah. So then x, if I flip the sign, now we can, so that is 6. We can do the push down, and then is minus 2, okay, dividing by minus 2. So then x is, so the answer is x is less than equal to minus 3. Yeah, okay, is that right? Yep, that is for part B. And then part C, please do part C yourself, okay? It's the same principle there. You just, well, you move stuff around, and then if you have to divide by a negative number, then you have to flip the sign. Yeah, actually, I will do part C as well, because I want to show you something. So part C, the C problem says 5 minus x. This is C. Oops. Okay, this is problem C. Okay, the C problem states that 5 minus x is bigger than 10. Okay, now we can do the thing like I did before and then divide by the negative number in front of it, -1, by flipping the sign. Or we can skip that part, avoid having divide by negative numbers by making sure x is positive all the time. So we're going to move x over. Okay, so then the 10, I'll move it over here. It becomes -10. And then the x, I'll move it to the other side. It becomes a plus x. And the purpose of that, then I don't have to divide by some negative number. Okay, so then x then equals to is less than -5. See, by moving it over, I basically did the same thing as dividing by the negative sign, because now x is less than something instead of bigger than, because it started out being bigger and now it's pushing it to the other side. You change the sign, it becomes less than, and that's still the right answer. So basically, you're just getting the right answer in a slightly different way. So I don't have to reverse the inequality sign, so I don't have to remember to do that, okay? So if you keep x positive all the time, you don't even have to worry about anything like flipping the sign. You just so basically the normal equation solving tricks work for all inequalities as long as you remember to keep your x positive, okay, by moving it across. So that's example 4. All right, moving on. Let me clean off the board. Next, let's do example 5. We have this particular problem where 13 minus 7x. What happened here? I forgot my bigger than. The bigger than or equal to 10x minus 4. Now, in that case, I am going to do, like I said a little earlier, I want to keep all x's positive if I can. Okay, that way I don't have to worry about flipping the sign. So let's keep all x's, since when you look at this, the positive x is here, a negative x stuff is here. So move every x to this side. So I'll write down the 10x, and then that becomes a plus. Move it over. It works the same as the equal sign. Okay, basically. And then if you keep your x's positive, so then move it over, and then this side becomes 13. The -4 will become positive. So then so far so good. And then we have that becomes 17. X is less than, that's also 17. So then x is less than equal to 1. Okay, that's how 1 is bigger than equal to x. However you want to read this, and that should be the answer. It is. Okay, and then we'll also represent it in that notation. What is it called? Whatever it's called. If this reads as 1 bigger than equal to x, or x is less than equal to 1. So if x is less than equal to 1, so the biggest it gets is 1, right? And then it goes all the way to -infinity, parentheses. So that's another way of saying this says exactly the same as that. Okay. Normally we don't even need to write down both, because being that they say the same thing. We're just doing that here because we're just introducing that notation. So we'll write that too as a reminder of what this thing means. Okay, that just means x is less than 1 or equal to 1 due to the bracket. Bracket means equal, includes 1, parentheses not including. So next, let's look at example 6. Let me see. So we have a similar thing. Now we have a bunch of fractions. Well, fractions changes nothing. Okay, we'll just do it the same way. So for example 6, we have something like this, and what we're going to do, this is a bigger than or equal to sign. Let's move this thing to this side, okay, because I want my x to be positive. That way I don't have to flip the inequality sign. If you don't want to bother with that, don't forget to flip the inequality sign when you divide your negative stuff out. Okay, so I will move it over here. So I have 3/4 x plus 2/3 x, and then this move to the other side becomes a positive 5/8. Okay, and that equals to, now we are just going to do fractions. Come on, Okay, now what is that? That equals to something like 12, okay? And then 3, that becomes 9 plus 8, right? X. And that side is still 5/8. Okay, and then 9 plus 8 is, so now we are going to do that cross multiplication thing, which also applies to inequalities as long as you're not dividing out something negative in front of x. Okay, so we'll do that. Then x will be equal to 7, we'll push this is 17, we'll push the 17 down here, so 8 times 17, okay, and move the 12 up, across up, so this is 5 times 12. And that is what x is once we calculate what this thing is on some calculator. And that is going to be equal to, okay, that we can cancel out 4 here, that will be 3, okay, and cancel out the 4 here, that will be 2. So x should be, if I didn't mess up, 2 times 17 is 34, and 3 times 5 is 15, and that's what it's not equal to, I wrote that wrong, is bigger than. Don't forget the bigger than, because we're not doing equal right now. So I turned it around, so the smaller side has to follow. X follows the you know, there's a point here, right? So x follows the point. So that is what I got. Yep, that is correct. X less than 15 over 34. And writing it in the set notation or whatever this is, then being that x is less than 15 over 34, then less than or equal to 15 over 34, then you write the bracket, okay? X goes all the way up to that, and then goes back less than all the way to negative infinity with a parenthesis sign on the left side. So that should be it. Okay, next we are going to do something called compound inequality in example 7. Now, what happens when you have like two things like that? There's no such thing in equality problems that in this kind, okay? It just this only happens in inequalities that you have two symbols. Now, when that happens, all you do is this is just two problems. You solve them both together. Well, not necessarily at the same time. You solve them one at a time. Okay, so we have 3 less than equal to 2x plus 2. That's the first situation we have to fix. And secondly, the 2x plus 2 has to be less than 6. So we'll solve each individually and then combine the answers, so to speak. So the first condition to be satisfied will mean that we'll do the same trick. Okay, so this is 3 minus 2 by moving 2 over here. And then this is just 2x. So we get, sorry, why did I say 3x? It's 2x. If this thing is 2x, okay, so that is 1 is there's 2x here, which means x has to be 1/2, right? So x, this reads as x is bigger than 1/2. Okay, I mean this is the big side and this is the small side. Think about the inequality that way. So so x is on the big side, so x is bigger than 1/2. So that just comes from here, and we're not done yet. We need to do the same thing on this side. So I'll stand here. Yeah. Okay. So we'll pull the same trick. So then 2x is less than 6 minus 2, and then which is 4. So x is less than 4 over 2, okay, and then which means x is less than 2. So we have these two conditions. So x has to be both bigger than 1/2 and less than 2. Okay, both conditions has to satisfy. So we can write it like this. So the answer then is we'll write it as x is bigger than less than 1/2 and less than 2. And the set notation, then we will write it as the bracket 1/2, okay, comma. So that includes the 1/2 and then 2 parentheses, because it doesn't include the 2, but it includes everything in between these two numbers. And that should be our answer. Let me see. Yeah, that looks right. Always awesome, right? And so that's that. Let's look at next. Solve a compound variable in all three parts. Okay, now in this equation, we notice that we only have the x in here. There's no x on both ends, right? So now let's make it more interesting by putting x's on here and here. So that is example 8. So let's do example 8. We have, okay, so 3 plus x, which is bigger than 7x minus 2. Oops. (7x minus 2), and then which is bigger than 5x minus 10. All right, so here it is. Now there might be x's in there, but we really don't care if there are x's here, there, wherever. We're gonna do it the same way as this. So we have then two equations. Okay, this is the first part, and the other one is the second part. Now let's work on the first part, which just includes this part. Okay, so then if we do just this part, then here's the bigger than, we'll move the x to the other side, so it becomes 6x because 7x minus x, and then move the 2 over here, then 3 plus 2, right, is 5. So then we have x is 5 over 6. Is less than 5 over 6, or 5 over 6 is bigger than x. So that's the first two things. Then next, we're going to work on the next two items. That is just this part. The next part, we focus on this situation being true, okay? And to solve this one part, then we have 7x, move the 5x over here, so that becomes subtraction. Then we will have 7 minus 5 is 2, so we have 2x left. And then move the minus 2 to the other side, it becomes plus, so if it becomes minus 10 plus 2, that's minus 8. So then we have x is bigger than negative 4. So together we have this situation where x is less than 5, 6, but bigger than negative 4. So we'll rewrite it the other way, okay? So in other words, we're going to write this as x is bigger than negative 4. Okay, put the smaller numbers on the left side, and then less than that thing, 5, 6. Or in the set notation, that would be, these are all parentheses because there's no equal sign here. And so we go from minus 4 all the way to 5, 6. And that should be our answer. And it is, okay? And I should also point out that this can also be then demonstrated on the number line like this. Okay, it goes from minus 4 with a hole there. Okay, that's a little hole. Remember, this hole looks big, but it only includes negative 4, nothing else. Not negative 4, 0.00001, nothing. Okay, it just negative 4 itself. It goes all the way from negative 4 to 5, 6, and that's the entire set. Every number in the blue is part of our answer collection. Okay, that's what that means. Next, let's go to page 167 and consider absolute value inequalities. Now, the absolute value inequalities has basically two situations. That is, either you are less than something, the absolute value, or you're bigger than something. Okay. Now, if it's less than something, that is the same as saying x is between the value and the negative value of the same k. Now, why is that? Let's consider, for example, let's consider something like, I'm making this up, okay? Say absolute value of x is less than 5. Oh, my mark is very dim. Give me a second here. Now, let's say absolute value of x is less than 5. Now, what kind of stuff has absolute value less than 5? Well, x might be, say, 1, right? Absolute 1 is less than 5. And then it can be, Now, it can be 1, right? 1 is definitely absolute value less than 5, or 3, that will work too. It can also be negative 3. Negative 3 for absolute value means you kick the negative sign out. It's just 3, it's still less than 5, so it's negative 4. Now, the difference, however, here is once you get, say, if you get up to be 7, a positive 7, okay, that will not be less than 5 anymore. And negative 7 is the same way. If your x is minus 7, that no longer holds because you kick out the negative sign. It's going to be, is no longer less than 5. In general, for x to be less than 5, what happens is then that's the same as saying x has to be bigger than negative 5 and less than positive 5. So anything that is between the positive and the negative value of what the absolute value is less than will work. And that's why we say that if x's absolute value is less than k, then it's the same as saying that the absolute value is less than k itself. I mean the x is less than k itself or bigger than the negative of k. See, because this situation will fit this. Every number in this range will fit into this this absolute value equation. Now, what if we have the sign flipped? That is, what if we have x absolute value of x is bigger than, say, let's say 7. Okay, now if it's bigger than 7, what kind of number has absolute value that's bigger than 7? Well, let's say, how about 8, right? Positive ones such as 8 or 9, that will work. But if you think about 3, that's not good enough, okay? 3 is not bigger than 7, absolute value or not. So anything that's smaller than 7 is just not going to work. However, when you consider negative numbers, anything that's negative enough will work. For example, negative 8, okay, or negative 9 will also work because when you put it in here and slap on the absolute value, the negative sign disappears. So any number that's big enough or negatively big enough, either way will work. So in short, we need, for this to happen, we need x itself to either be bigger than either be bigger than 7, or x has to be less than negative 7, because being less than negative 7 means that it's like negative 8, negative 9, negative 1,000, and when you slap on the absolute value, you kick the negative sign out, and then the negative 9 will satisfy the inequality. And that's why the second equation, the second situation works. That is, if for absolute value to be bigger than a number, then you have then the x has to be either less than the negative number or bigger than the positive number. Okay, so both sides will work because of this situation. So now that we know that, you have to remember this. In general, remember that the absolute value less than a positive number is the same as saying it's in between. Okay, if it's less than, that means it's in between those two numbers. And then if it's bigger than, then it's either on one side or on the other side. Okay, no, there's no middle ground here. Either one will work. All right, so example 9, it says describe all values within a distance of 4 from the number 5. Okay, so what that means is that we will, draw the point, we'll draw the number line. All right, so x absolute value of it goes from 5, the distance of 4 from the number 5, we'll call it this way, okay? X from 5, the distance from 5, we'll call it x minus 5 in absolute value, and that has to be within the distance. So if the distance is less than 4. I'll put it another way on the number line, okay? Here's 5. So we measure 4 this way and 4 the other way. And so it's within this range. So what is that point? It's 4 from 5, so on this side, so it has to be 1. And 4 from 5 on this side, it has to be 9. In other words, this thing at x, then, it has to, x is somewhere between, x then is in between 1 and 9. That is the answer to this thing. Yeah, okay. So that is the solution to, is it less than, does it say equal to? Yeah, equal to is okay. Yeah, less than, or equal to is good now. We're not too picky here. So we'll call that, or another way of writing it in the other notation is 1, 9 using brackets to include both ends. And that, yep, that is that. Okay? So that's example 9. Next, let's do example 10, where, example 10 says on page 168, example 10, where we have the absolute value is less than something, less than equal to 3. Now, remember the rule where it says if the absolute value is less than something, that means the value itself has to be less than the number and bigger than the negative number, like this. So we write this down. X minus 1, okay, then is less than equal to 3 and bigger than or equal to the negative of 3. By saying that, we're following this rule right here that we saw a little bit earlier, the first rule. Because it's x less than k is the same as it's stuck between the negative and the positive values. So that's what I have right here. And then this becomes a we don't need a negative sign here. I mean, we don't need the absolute value sign here. The whole point of writing this is to get rid of the absolute value sign. And then now we solve it like we solved before, the two equations. So we have, for this part, okay, we have x, move the minus 1 over here. It becomes minus 2. Minus 3 plus 1 is minus 2. And then solving this equation, we have, we'll still have x on this side, move the minus 1 over there. So that's 3 plus 1, which is equal to 4. When you move the minus sign to the other side. Okay, so then x between 2 and 4 should be the answer to 168. Yep, that is. And in the other notation, being that it's less than or equal to, we'll use brackets. Minus 2, comma 4. That will be in the, what is that? Set notation, sum notation? Whatever. The point is, that's what that is. So finally, we're going to do example 11, where we have, given the equation y equals to 1/2 absolute value of 4x minus 5 plus 3, determine the x values for which the y values are negative. In other words, I need this thing, this is example 11, I need this particular thing here to be negative. That is minus 1/2 absolute value for x minus 5, okay? This thing and plus 3, this whole thing need to be negative. Yeah, negative is less than 0, right? Okay, and then we will, so we're going to solve this thing, well, just like we've been doing. So first, we'll push the plus 3 to the other side. So we have, so we have this thing, 1/2 absolute value for x minus 5 is bigger than, smaller than, that's a smaller than, not a bigger than, less than negative 3. Next, we are going to divide both sides by the negative sign to flip the sign, because I don't like the negative sign there. So we'll flip the sign, and then we'll multiply both sides by minus 2. Okay, so to get rid of the fraction. So 4x minus 5 is multiplied by 2. That is, I'm multiplying both sides by negative 2. So it becomes positive 6. Positive 6. Okay. Now this is the same as writing equations on two equations, which I will write down here. So 4x minus 5 is bigger than 6, okay, and less than, and then less than negative 6. No, sorry, this is a bigger than. I said that wrong, because for bigger than, we have two situations. It has to be, we don't write it this way, okay, because that wouldn't make sense. Because let's remember the formula. It has to be less than the small number and bigger than the bigger number if the absolute value is bigger than. So see, the absolute value here is bigger than a positive number, which means we have to write down two equations like this. Less than the negative number, bigger than the positive number. Okay, so that's one of the equations, okay? And the other one we need to write down is 4x minus 5 has to be less than the negative version, which is negative 6. All right, and then we'll have to do both solve both inequalities. Now let's do this one first. Okay, so move the 5 to the other side. We have 4x is less than, that is minus 1. So gives us x less than minus 1/4. 4. All right. And then this one, move the 5 to the other side, becomes a plus. We have 4x bigger than 11. Okay. So then x is bigger than 11/4. So we have two answers here. One is on this side, which is less than a negative number, and the other one's bigger than some positive number, as this kind of thing tend to be. Now that I've done that, let's see if I got it right. What are we doing here? 11. 1/4. Where's the answer? So yes, well, the book didn't even write it out. Whatever. The point is, the answer is either x is bigger than 11/4, okay, which is 2.75, or less than 1/4, which is 0.25. As well, your book drew the graph for this thing, which I don't really see the point of doing that right now. So I won't be asking you to do any graphs in this section. We'll do graphs on a later section when we focus on graphing. Okay, because graphing is quite involved and it takes more than just a quick solution to explain it. But the point, however, is that x is, if you look at the graph, you notice that for this solution to make sense, we have to, for this side and the other side, actually, I don't know how much that really matters. The point is, that is the solution, and that's what we're shooting for in this section. So we have now come to the end of this section. For homework, please do on page 169, problems 9, 13, 17, 19, 21, 23, 25, 29, 31, 37, 43, 45, 47, 49, 51, 53, 59, and 61. Now there's a bunch of about 5 or 6 problems in there that is just about set notation, so they are very fast. So that even though it, like this thing, you have to write down this thing, which is a one-step deal. So even though there seem to be more problems than usual, there really isn't. Okay, and so please go do your homework, and when you're done, I want to talk about some of them. Oh, I changed my mind about a couple of problems in the homework. I decided we're not doing 37, and instead we'll change it to problem 22 instead. They're the same thing, basically. Anyway, so let's look at problem 13. We have this fraction situation here, but we're going to solve it the same as if this is an equality, bearing in mind to try to keep x positive, okay? And if we have to divide by a negative number, then we will have to flip the sign. Otherwise, it's exactly the same way as we do equality. So to do this, then we will have, there's some numbers down here. We will, change it to 5 times 8 is 40. Okay, let's put it as the common denominator, so then everything's happy and we don't have to think about it. So let's do that. So for the common denominator to be 40, we will have 40 here, which gives us times 5. Okay, so 5 times x plus 3. And then this one is times 8, so it's 8x plus 5. And that will be bigger than or equal to 4. That's 12, okay? And everything will be over 40. Now, in that case, we will have, let's see, we can now ignore the denominator because they are all the same. So we will knock them all out by multiplying 40 across the board, okay? So we only have this stuff left. So what do we have? We have 5x minus 8x, that's negative 3x. And then plus 15 minus 40, right? That is negative 25. And that is bigger than or equal to 12, which means I'll put the x on this side because it's negative. So 3x on this side. And then this will be minus, move 12 over there, becomes negative 12, negative 25. That will be negative 37. correct? I hope so. So I might have made a mistake in here. I'll check. Anyway, so x, I got then x is less than or equal to negative 37/3, which is, let's see, what problem is that? Problem 13. Let's see. Oh my, I'm right. Okay. And then the book's notation want us to write it like this, being that x is, remember x is less than, is on the small side of the triangle, right? Less than this stuff. So x is on that side. And so we'll write down the number here, this odd number, and then comma, all the way to negative infinity, okay, and parentheses. And that is the other way of saying the answer. These two say the same thing. And I guess your book wants you to write it this way. So which is fine. We'll write it like that, okay? And that's that. That's problem 13. Next, let's look at problem 21. 21 says the absolute value of something is less than a negative number. That is not possible, okay? All absolute values, by definition, means you kick out the negative sign, so that it's positive. So for it to be less than a negative value, that is impossible, which means there is no solution to problem 21. And then next, let's consider problem 22. 22 says the absolute value has to be bigger than a negative number. That is always true, okay? And I mean, every number you can think of, this absolute value minus 20, whatever, the absolute value will be bigger than negative 1 because all absolute values are positive or at most 0. It cannot be negative. Therefore, the solution to 22 is called the all real numbers system. If you were to write it down, remember that in your book is for all real numbers, you can write it like this, okay? The answer to this, it will be negative infinity, comma, infinity. That means you go from infinity that way, clear to infinity the other way, all real numbers. All right, so that is that's that. Next, let's look at problem 23, which we have an actual absolute value problem to solve. All right, so let's write this down. So the absolute value, this is problem 23. All right, and then the absolute value of x minus 3/4 is going to be less than 2. Okay, now because this is just 4, we can take it out of the absolute value sign because it's a positive number, its absolute value is just 4. Okay, so we will rewrite this thing as x minus 3 absolute value is less than, move the 4 across to become, when it's under here, under the division sign, you move across and to become multiply. It's like cross multiplying, so this is 2 times 4. 2 times 4. The dot means times, so that's actually 8. So we have our equation then becomes x minus 3 is less than 8. Now the absolute value of problems solved this way. If it's less than, okay, remember this formula on page 167. If the absolute value is less than some number, positive number, then it's the same as saying it's less than the number and bigger than the negative number. Okay, the first formula is what I'm following. Because that's our situation. So this being written like that, we will rewrite it as x minus 3 is going to be less than 8, okay, and then bigger than negative 8, following this formula that I just showed you, the first one right here. See, is and once you write that down, then you just solve each. This is the same as 2 inequalities, and you solve each one accordingly. So we'll do that. First, let's solve the first one, okay? The first one says, we'll write down x, move the negative 3 over here, becomes positive. So it becomes minus 8. Minus 8 plus 3, that is just minus 5. So that's the solution to the first part. The second part, we have, we have x here. Inequality, move the negative 3 to the other side, becomes a positive. So 8 plus 3 is 11. So that is x bigger than this and less than that. So we can write it together as, so x will be write it like this, 5 and 11. Okay, that makes sense. So we have the situation is anything between 5 and 11, not including the endpoints, because there's no equal signs here, not including the endpoints. Anything between negative 5 and positive 11 will be our solution set. Or write it another way will be minus 5 parentheses, comma, 11, and close parentheses. That says the same thing. So that is that's problem 23. Let me check. Yep, minus 511 is what the book wants you to write as an answer, and that is correct. But this one is just as good, okay? There is no difference, really. Next, let's look at problem 59. Now, problem 59 has an equal sign. It's not unequal. Now, we are in the inequality section. Why are we doing an equal problem? I don't know, but the book wants us to do it, so I guess we'll do it, okay? We can just consider what this means. Now, for absolute value of two things that are equal, then either they have to be either equal, or they can also be opposite signs. For example, you can have 5 equals to 5, right? Or they can have different signs, such as negative 5 is also equal to absolute value of 5, like this. So we have two possibilities. Either this thing equal to that, this is the first most obvious possibility, x plus 3, or it can equal to the negative of that thing, 3x minus 1 equals to the negative of this entire works, 2x plus 3. Those are the two possibilities, and it will give us two solutions to the problem. And so we just solve these two fairly easy equations, and that should give us the answer. So we're going to do that. The first equation, we will solve it over here. Okay, the first equation, I'll write it as A, and this will be the B. Okay, to solve A, we'll have 3x, move the 2x over. That 3x minus 2x will have x. And then move the minus 1 over. That becomes 3 plus 1, which is 4. So that's the first solution. And then the B part of the solution, I will... similarly, the B part of the solution is we have 3x, okay? This is a minus 2x, move over, become plus. So we have 5x on this side. And then minus 1 move to the other side. The other side has a minus 3. And then minus 1 move to the other side becomes plus. So then x then equal to minus 2 on top. And then divided by 5. That push the 5 down across the equal sign. Okay, so that should be our two answers to this problem 59. Let me check. 2 and negative 4/4. Why is that? Maybe I made a mistake. Let me check. I did make a mistake. Okay, the problem says 3x plus 1. There is no negative here. Okay, now that really changes a few things, right? So let's do this again, except that there's a plus sign here. Otherwise, everything else is the same. Now, if there's a plus sign, then this is definitely wrong. So 3x minus 2x is still x. And then 3 minus 1, okay, this 1 move over there becomes a negative, so it becomes 3 minus 1, that is 2. All right, so that's so far so good. Next, we have this situation, so this becomes 5x still. This plus 1 moved to the other side becomes minus 1. So this is 3 minus 1. So then this becomes 4. That's where I messed up. Okay, so that is 4. Now, how does that sound? Minus 4. Yep, that looks much better. You know, it really helps when you don't write the problem down wrong. And anyway, so that's that. Next, let's look at problem 61. Now, finally, we're going to do a problem 61 where we have a fraction situation. But unlike the earlier fractions where we have just numbers on the bottom, we have an x on the bottom as well, okay? But we're going to use the same principles to solve this inequality. Now, to do that, first we specify, well, the book specifies that x cannot be negative 7, because if it is, then the denominator will be 0, and that is not possible, okay? We cannot divide by 0. So having said that, we remember that x plus 7 is not 0. So we are going to multiply both sides by x plus 7 because there's a 0 here. So let's multiply everything by x plus 7. Now, first, we assume that x plus 7 is bigger than 0. So assume that x plus, in the case where x plus 7 is bigger than 0, then we can multiply it and not change the sign. Bigger than 0. it cannot be equal to 0, right? Because x is not negative 7. So in the case where this is case 1, okay? Case 1, x plus 7 is bigger than 0. We multiply both sides by x plus 7. We don't have to flip the inequality sign because x plus 7 is positive. So we have x minus 5 is less than equal to 0. And then so x is less than 5 when we put 5 to the other side. And this is another way of saying that x is bigger than negative 7, right? So x less than 5 and x has to be bigger than negative 7 such that x plus 7 is bigger than 0. So those two conditions, we can write it together as x is bigger than negative 7, okay, and then less than 5. So that is one solution right here. Now the second solution is what if the second situation is what if x plus 7 is less than 0? Remember, it cannot be 0, okay? So if in the case where x plus 7 is less than 0, we multiply both sides, then we have to flip the sign. So then x minus 5 then we have to flip the sign, so then it is bigger than or equal to 0, so which means x has to be bigger than or equal to 5, right? And in this case, then at the same time, x also has to be less than negative 7. X less than negative 7 at the same time. Both these conditions has to hold. Now that is not possible, okay? There's no number that's both bigger than 5 and less than negative 7, so this option is rejected. Therefore, this is the only solution we have right here. X is between negative 7 and positive 5. And so we'll write that as, can x be 5? Yeah, x can be 5. I forgot to write down this part. There's an equal sign here. So then x can be 5. It just cannot be 7 because that makes the denominator 0. So the solution is this one, or write it another way will be parentheses negative 7 and then 5 bracket. Okay, parentheses for the less than, bracket for the less than equal to sign, and that is the right answer. And that should mark the end of this section. I should mention that I haven't gone much into the graphing part of this section. That's because I feel that the book has treated it very lightly, whereas graphing is actually quite complicated. So I will prepare for this to be done in a later section to exactly how to graph, especially inequalities. There's a lot more involved in it. But for now, let's not pay attention to graphing and just figure out how to do the algebra part, okay? The numbers part, and then we'll deal with the graphing at a later time.